All right, so we are on our final stretch of Python fundamentals. And our last topic is basically how do we input and output information. And that input and output can go to screen, basically input something from the user or print something back to user. And the two commands for that are input and print. And then it could also go to the file. So one basic thing to remember about files, if we are doing a very basic file, like in this case, just a text file, then I have to open the file, meaning basically designate a location on the computer and name it, okay? And that name is something that we see and we search for. And then open it in certain mode. It could be for reading, writing, or appending. And then I write to the file, and for that command write, that kind of travels with this object file that I created. So Python is an object-oriented language. So a lot of times when I define an object, I have a whole bunch of routines that are working and defined with that object. And in this case, when I open the file, and I name it my file for my reference in the computer, in the programming part, then I can just say myfile.write. And then it knows that it's writing to that file. And I can also do some NumPy arrays. We're going to get to that in a second. But essentially, there are two things that I have to recognize when writing into files. Whether I'm just writing text for somebody to read, those are the simplest files. But for that, these days, you can send an email. But you might want just to save that information in a file. But most often, we're concerned with some data and including it in the file. And the text that accompanies data is just saying something about the data. Okay? So it's telling the user what is data about. Data is just, if I just include numbers, I don't know what those numbers are. So I often have to include something for the user of that. So we typically have a combination of text and data. Okay? And I have to close the file once I'm done. Okay? So I can also, of course, read, write, or do whatever with the file. So open, do something with the file, and close are the basic motions. In our example that we pushed through at the end of last class had opening a file. I called it a simple text file. Then I use this command write. We're playing with names and ages. So I had variables name and age stored. So I could actually combine them into write routine similarly to print. Okay? And there's one special character that is often useful, and that is /n, that basically tells computer, hey, go to the next line, so the text is not pile up on top, like one information on top of the other. And I can write as much as I please. It will just keep doing it. And then after I'm done, I have to close. So those are the simplest text files. Let's actually now read one of those files. And this is actually temperature data. You can download the file temperature.txt. It's on Canvas, so please take a moment to do so. So as you're downloading that file, I basically have here on the screen, which I should put in a presentation mode, though I will go into my Anaconda for a second. So I'm just going to put this file like this. So what you're looking at the screen is the information that is in the file. If you attempt to, so please download that file and put it wherever it is that you keep all of the Python notebooks and all that for this course. Only you know where that is. Smile. If you know. If not, that's what search command is for on your computer. But try to get organized, because as the semester progresses, it's going to be trouble to find all of the files for all of the different courses you're in. If you were in one, that would be simple. So this is the information. So first thing I have to look with like text files. First thing I have to do is look at what I have. Okay? What I have is one line of text, which is simply telling me, the user, what's following. And then I have 4 columns of data. There's month, high temperature, low temperature, and average temperature. What does it look like? What is the temperature in? Is this Celsius? Is it? Do we have often 80 Celsius degrees? No. So this is Fahrenheit. Good. So, for instance, that top line should have told me this is temperature in Fahrenheit. Okay? It didn't, because whoever wrote it didn't think to include. So never fail to use your logic to assess what the situation is. If this is temperature, it's temperature. So the file name says it's temperature. But obviously, first thing I want to check is like, well, is this Celsius or Fahrenheit? Is this in Austin?
No.
No. Why?
Too cold.
Too cold, right? So I think this is Portland Airport, by the way. Because high of 80 in summer, isn't that beautiful? Anyway, it's certainly not in Austin. The highest degrees they have, like, is 80 degrees. Look at that. Anyway, so this is temperature in. So let's now, it's nice. We actually now look at it. We actually understand it. Now I would like to do something with it, like plot it, right? Well, for that, I got to read it in. So let's go through the procedures. Okay? You will open the file, but first you had to look at it to understand what's inside if it's a text file. Okay? Then you will read the text lines, line by line. There's only one here to read. Then we're going to read the numerical data, close the file, and then we'll actually do something with that data. Okay? So go ahead and say, my file open file name, and I want to read, so I'm going to put the mode as R. Okay? And then there's that one line of data you want to read. And there's a command for reading just one line. It says read line. If I say just read, I'm going to read one character. That's too slow. And, Do you know where is your temperature file in the same? So you can come and look into this over there. So it should be the same. Are you in the same directory as your Python notebook? So it's not executable. And then this first line, I just stored it. You can print it if you want it. I don't really need it. If you print it, you're going to see this month, high, low, average. Okay? What you will need for your homework is that you will need to read multiple lines. So for your homework, you're going to get to read a file that stores a well log. Okay? And that file has, I believe, somewhere between 14 and 20 lines at the beginning. So what you can do is actually say read line, and you can do 20 of them or whatever, however many. So just remember that for your homework. So now that we read this one line, this is not what I need. I'm just kind of discarding it. I need the numbers. Okay? After that, I need NumPy routines because I want to actually read this data into a larger array. So I'm going to import NumPy as NP. And NumPy has a file reading routine that reads from file So I have 4 columns, 12 months, and for each of those months I have 4 pieces of information: month, high, low, and average temperature. So I have altogether 48 numbers I'd like to read in. So this command from file is going to go from the file, tell it where to go to read. This is float type data, so this is real. Real numbers we call float on computer. So from this file, read floats. How many? Count is how many? 48. You can just type in 48. I wanted to point out that there's 12 months and 4 pieces of 4 numbers per month. And they're separated by space. They could be separated by comma. They could be separated by all kinds of things. So in this case, it's just simple. So just basically read this many numbers and recognize if there is a space in between them, recognize them as separate numbers. And that's actually cool. That's going to read in all of the numbers and say my file.close. And then I want to check, so did everybody close the file?
Why do you need to close it? What does that do?
So if the file is open, there is an open access to that piece of memory. And that can, if your system suddenly shuts down, there's an open access to it. Like you left the door open, cat could go out.
Okay.
Okay? Close the door so the cat doesn't run away. In my case, a dog or 2 toddlers. Either way, I close the door, and I have to lock the door with the bolt because the toddler brings in a little chair and opens up the bolt these days. Anyway, too much information about my evenings. So essentially, there could be data corruption because computer has an access to that file, and it might accidentally, power shuts down or something happens, it could write something into that file. The moment it does, that's data corruption. Something came in and has overwritten the data you had there. So with closing it, you're kind of closing that door so it doesn't happen. It just stays on the drive. Okay? And most often, nothing will happen if you don't close until it does. So sometimes cats don't go around toddlers don't go up. But when it does, then it's painful and you don't know what happened. Okay, so it's just a measure, safety measure. And then you want to inspect, okay, what did you got? What did you read? Did you read things correctly? Okay? I'm gonna check the data. So what is data? Because NP created this, NumPy. It created its structure in the array, which is good. Our 1D arrays and 2D arrays are this class. And then I can see all of the numbers all in one actually array, right? You can check the shape of it. You can put data.shape. It's all in one 1D array. Okay. All right. So now to actually reshape it, I can simply tell it, well, give me 12 by 4, will you? And then the data will look precisely the way you saw it in the file. But this is an array, 2D array in this case. So this is my visual verification that I actually read the data as data is. For all kinds of reasons, this could have gone wrong. If I specified the wrong count of the numbers, if I specified integer instead of float, like there's a lot of different ways you can actually corrupt the data because you don't interpret the bytes that are storing this information correctly. Okay. But this seems okay. If you haven't, following you. Now I want to do something with it. And this is going to be your assignment, and it's going to be counted as a quiz. You will have till tonight to complete it, but start now. Try to finish it now. I want you to plot these temperatures as follows. I want high in red diamonds, low temperature as blue circles, and average temperature as green crosses. And I want this plot annotated, so I want label, month label on X, and temperature label. This time properly, be a proper engineer, mention that those are Fahrenheits. I'm going to give you a couple of more minutes to work on this. I don't want to solve it in front of everybody because that's not the point of a quiz, is it? I'm just going to ramble about it. Somebody got it? Somebody plot something?
Wait, no, not that. No, just the word.
Some numbers. You plotted some numbers. The correct ones.
I shouldn't say that.
Oh, no, because scan isn't very well. And it would give you that two options. Oh, right. Yeah, great. Just put, for example, 1 equal to, oh, and just write 1 equal to, what equal to data. New story, so what equal to, oh, at first assign, oh, yeah, at first assign. You call it a layer of system. So you save it and start. Yeah, just wait.
So I could print data. Let me help a little. What is this? What is data colon, comma 0? There's information in my first column. Right? Data is this. Okay. Then how do I get my second column? It's column 1 because I start from 0. So there's column 0, column 1, column 2, column 3. Now this is just printing it. You gotta do something with it in plotting, right? So column is substitute for everything. Okay? It's really 0 through 13. 0 through 12, I'm sorry. Okay? 0, 1, 2, all the way to 11. So I have for 12 numbers, I have 0 to 11. Yes? But if I'm just taking everyone, I don't need to specify the range. I can just do a shortcut. Now I told you everything. Almost. What do you want me to go back to? Picture? You need this. So first somehow plot the data, then worry about making the plot pretty. First step, plot it somehow. I created it. Oh, that's right. Published in-class plotting assignment. All right. Let's move on. You can play with it a little. By now, you should have most of the information that allows you to complete this at your pace. So if I now want to actually write this same data back to file, let's do this exercise. Okay? So I'm going to create a new file, and I'm going to open it for writing, W. And then I'm going to write that first line to that file, including jumping to a new line. And then I'm going to use, there is a same command that reads NP, like those NumPy arrays, or reads into a NumPy array from file. There's a command that writes data. So these are commands that are efficient for writing actual data. And the format I'm going to give it is just string. So it's going to be basically a text made out of these numbers. And I'm also going to separate these numbers with space. And then I'm going to close the file. So I'm opening a new file, and I'm calling it temperature_new, just to test whether I know how to write this data back. Maybe I modified the data. And I'm going to open this file for writing, right? And I'm going to put that first line, whoops, into it. You can write anything else. It's up to you. And then I'm going to write the data. So this is writing the text that explains the data, and this is the actual data. And this is that NumPy feature. Just like I can do from file, reading something from file, I can put back to file. So I'm going to put this data to file. Which file? This new file. Separated by space. Don't forget the spaces, otherwise you will have no separation between your numbers. And format it as a string. That will basically format it as text, just like I interpreted that text. And close the file Again, don't let the cats go out. I'm gonna execute the code. And again, all of this that we're typing in, you have in a Python notebook called Lecture 2.6, by the way. So I'll just be lazy today and execute mine. And question is now, well, nothing happens. Do I know that the file was actually written? How do I check? I'll go and find that file. In the mess of the files that I have, there's temperature new, seconds ago. So I just saved it. Here we go. Here it is. Is it the same data? It looks like month 1, 3 temperatures, month 2, 3 temperatures. It's just all output as one. It's not output as table anymore. But frankly, I don't want to go through the pain of outputting 12 lines separately, so I'm just going to leave it here. As long as the data is in. But this reading and writing is about small details. Okay? So I'm going to let it be. All the data is in there. It's not very readable. I could actually modify it from here, by the way. I could go and edit it if I felt like it, and so forth, and then just save it. Okay? So this is a text file. You can modify it after writing the data. And since I'm OCD today, I'm going to do that. I have days when I'm a little OCD and days when I'm not. Oh. Somebody figured something out. Okay. So this is text files. Questions? Everything is super clear. Oh my. Alright. Another way to save the data, which is more efficient in terms of disk space, but you trade that with being able to read it, open it, and see what's inside, is saving a so-called binary file. So it's more compressed. You can't necessarily read the data in. And then it's actually super easy. You just say np, this is a numpy command for numpy arrays. You just do np.save, you tell it the name of the file, temperature.npy, and data. Data is the data you want to save. So this is just dumping this entire array, and I would suggest that you do this only one array per file, don't do multiple. This opens the file for you, writes the data, and closes it all at once. Okay, so there's no you directing all the steps. And if you need it back, you can just load it. So let's do this. Okay? Type in an Excel or something like that. You can just say np. Do I have the data? No, I didn't read it in here. So just type in np.save and save the data in. You can check in your little directory that this file has appeared. Okay. So if I execute it, and the next line just checks that whatever we save is the same as what we think it is, so I can load it from that file. So this opens the file for reading, reads the data, and closes it back. and this data 1. So if I print this data 1, I will see the same structure as data, which means that I saved it correctly and I read it back incorrectly.
It's like a faster way.
So this is a faster way, and it's memory more efficient. The problem is I can't open this NPY file for reading. So if I attempt to, this is what happens. So if I attempt to read it, I get error. Okay? It's not a readable file. A human can't go in to inspect what's inside because it's not a readable file. But it's faster. Okay? And it's more efficient for large data sets. So for large data sets, you actually don't want to save files as text. That is not good for accuracy, and it's not good for size on your disk. So just to remember, if you have 1,000 by 1,000 by 1,000 reservoir, which is discretized in blocks, like 1,000 by 1,000 by 1,000, right? That is 10 to the 9 information points. So let's say that you have porosity for 1,000 by 1,000 by 1,000. That's 10 to the 9 numbers. Okay? Per number, I can use, for instance, 4 bytes. So 4 times 10 to the 9 is 4 gigabytes just to store that data. And if I'm storing it as text, there's sort of an overhead that interprets that data as text. It's going to be much larger than 4 gigabytes, right? So in those cases, no, don't read anything, right? just dump it this way. So there's large information versus small information. So if I have this 48 numbers, it doesn't really matter how I store it. It's not a big deal. But if I have a reservoir type of information on reservoir scale, then that can be a problem. All right. That's all I have about input and output. We really just scratched the surface. I just really kind of want to let you know, because you will at some point have to save the data yourself. Are you going to use precisely these formats? It's a good question. That depends on the data you need to save. I just kind of wanted to let you know, well, this is how you do it. You can always explore for more. There's a number of other Python features which could be fundamentals that we don't have time to explore. For data analysis, if you ever go for an internship that has mixed data in terms of both information like names of formations and whatever associated numbers with it, then there's a pandas module that is really basically, it's kind of Excel on steroids, really, in terms of data analysis. Okay. So you might want to introduce, there are tutorials, numerous tutorials online. So these, I included one possible link, but there's multiple others. Okay. So again, the reason why we introduced Python in this course is that it's relatively easy programming environment. It's available for free. It's right now widespread, especially in engineering and data sciences, and it kind of works on all possible platforms. It's not very fast. It's not the fastest out there, but there are ways to speed it up, which we're not going to go into. Okay? So in that sense, it's right now one of the most used environments, and therefore it's good that you kind of train yourself to be ready to go in Python. All right. I'm just going to briefly introduce our next lecture that is going to be about programming. Okay. So now we want to actually, what I mean by programming, we want to start writing sequences of commands that are going to execute a specific thing we want it to execute. And most often than not, we want to control the way my program goes and also react to whatever. I might be reading in data from a disk and then doing something depending on what I read. So I don't necessarily know in advance what's going to happen, but I want to react accordingly. And that's what we essentially call control of the flow of data or a program. Also, I want to do repeated tasks. So what computers are really good at is doing something all over again, way better than people. But it's people who design what are the computers going to do. So you are the logic, computer is just the worker. But you have to tell that worker, okay, execute this 1,000 times, or 2,000 times, or 1,000,000 times, and while at it, as the data is one way or the other, do different things. Okay? And then the third thing we want to do is we want to create code that we will reuse. So we want to kind of, right now we've been just separating things into different Python notebook sheets. Okay? But I actually want to basically be a little more modular about it. I want to say, okay, on this different computer, recognize quickly where my data is and execute all the same and change something in a modular way. So I want to have sort of variables as input and output of my pieces of code so that I can quickly reapply. And that's going to be, we're going to actually start creating our own functions. So we have already seen functions. We know that cosine function in NumPy. Okay? I can call it for any data. Okay? And that's precisely what I want. There is a cosine piece of code somewhere that depending on the data you give it, it's going to output different results every time you execute. And that's this code that I keep reusing. So we have seen, we have used a lot of built-in functions. Now we're going to start creating functions on our own. So again, 3 things. I want to control the flow. In certain cases, I want to do one thing. In certain other cases, I want to do the other based on my data. I want to repeat things multiple times. There are 2 types of loops that do that. Okay. And third things, I want to create modular code that I can reuse all over again. So I want to create my own functions. And this is the lecture that I'm calling programming. So first thing I want to play with is these conditions. Execute something based on the data that I have. So we're going to call those operators relational or comparison operators. And basically they're going to compare 2 things and be either true or false. So for instance, if I type in a is equal to 2 and b is equal to 5, then you can see, hey, you're wondering, is a larger than b? So you can print a larger than b. The result in this case should be false. Okay? So feel free to change the numbers. You don't have to follow the numbers I have. Huh?
Is this lecture 2.6?
This is lecture 3.1, and there is a Python notebook posted already for it. This one, control flow. I'm going to retype all over again. So A is 2, B is 5. And I want to check, hey, is A larger than B? And that seems to be false. Well, it is false. Is A smaller than B? That's true. Is A equal to B? That is false. It's not equal. Right? So you can see where I'm going with this. I can introduce C, which is 10. And I can say, hey, is A less than B and B less than C? Is that true? Are both of these statements true? Are they? Let's check. Yes. So and will be true only if all components going into that and, first statement and second statement, are true. If I pile up more of them, all of them have to be true for and to be true. If the moment one of them is false, and is false. So let's quickly flip that. B is not larger than C. Therefore, this statement is false. So true and false is false. Okay. I can do or as well. So when I have or, it's this or that. So as long as one of those statements is true, I'll be okay. So let's try or. This should be true. It is true. However, if both of them are false, so A is not larger than B and B is not larger than C, then my OR statement is false. This is kind of an abstract exercise here that I'm doing, just to show you how you put things. You will be the designer. You'll be like, okay, data is coming in, rain is falling, lake level is rising. If lake level is larger than some critical level, send an alert, okay? You can program that. If lake level larger than this many feet, do something.
And you just Lecture3. So this is homework 3.1.
So what I posted already is a Python notebook.
Yeah. Need that for
I don't think so.